Here in Topeka, we get our water from the Kansas River. These large concrete structures, which are situated on the southern bank of the Kansas River, are called intakes. They can pull water through any of these inlets depending on the current water level of the river. Each structure houses 6 low-service pumps. In total, the 2 intakes have a pumping capacity of 110 million gallons per day. However, Topeka only consumes an average of 21 million gallons per day. Let's take a look inside. The water is pulled by the pumps through 47-foot tall circulating screens that filter out large debris such as sticks, leaves, and even fish. Once the water passes through the screens, it is pumped through these pipes to the primary presedimentation basin where the treatment process begins. This is the primary presedimentation basin. This is where chemicals are first introduced to the raw river water. Here, polymer is added to the water. Polymer is a coagulant, which means that it sticks to impurities, making them heavy enough to sink to the bottom of the basin, leaving cleaner water at the surface. As more water is pumped into the basin, the cleaner water on top flows into a trough, which leads into the secondary presedimentation basin where the process is repeated. From this point on, the treatment process is propelled completely by gravity. The 2 silos you see here are full of granular lime. The lime flows down and is slowly fed into 2 large mixers called paste slakers. The slakers mix the granular lime with water until the paste is created. This paste travels down from the slakers into a trough which leads to the primary lime softening basin. It is here that several chemicals are added to the water, including lime paste, chlorine, ammonia, and liquid alum. The 8 motors you see here turn large paddles that mix all of the chemicals together. The lime paste is used to soften the water. The chlorine disinfects the water, making it safe to drink. The ammonia creates chloramines, which maintains chlorine residuals throughout the entire distribution system. And lastly, liquid alum is another coagulant, similar to the polymer which is added in the presedimentation basins. Once again, the impurities get heavy and sink while the cleaner water on top moves on through the treatment process. About halfway through the treatment process, CO2 is added to lower the pH of the water. Towards the end of the treatment process, liquid fluoride is added for dental health. Phosphate is also added to help create calcium deposits throughout the distribution system. In essence, it creates a coating on the inside of the water mains, which acts as a corrosion inhibitor. From here, water moves on to the filters. Water comes in and filters down through a layer of anthracite and then sand. Anthracite is a porous substance which captures microscopic impurities, leaving the water crystal clear. As you can imagine, these filters get very dirty and need to be cleaned regularly. Twice a week, treatment plant operators reverse the flow of water to backwash the filters. This dirty water is discharged back to the river, leaving the filters clean and ready to treat more water. The filters are the last step in the treatment process, so from here, the treated water goes into underground clear wells, which serve as holding tanks until the water is needed and pumped out to the city for consumption. This is the on-site laboratory, where they take samples and conduct chemical tests to ensure that the water you drink meets the strict federal guidelines. This lab conducts approximately 70 water quality tests each day. Here you can see one of the lab techs performing a water hardness test. This room is known as the operator shack. It contains all of the master controls which manage the treatment process and the distribution system. Alright, we are going to backtrack a little bit. Remember all of that lime that we add to the water? Well, once it has softened the water, it eventually falls to the bottom of the basins. This is now called lime residuals, and it gets collected and pumped over to our lime residuals building. The lime residuals gets pumped into this large press, which squeezes out all of the water. What you are left with is a gritty, clay-like substance, which gets dropped into a semi-tractor trailer, which is waiting below the press. This lime gets delivered to local farmers who apply it to their fields to raise the pH of the soil. This in turn produces better crops. Well, that concludes our virtual tour of the water treatment plant of the City of Topeka Utilities Department, where our goal is to protect the health and safety of our community. For more information, go to topeka.org/utilities or call 785-368-3111.